welcome to Coding After Work. Before we bring in our guests, again, we want to take this moment to thank our sponsors, for without them, it wouldn't be possible. The first one is Progress Telerik. Now, Telerik supports the developer community with, for example, sponsoring streams like these. And our other sponsor is 1337 or 1337. And huge thanks to them for sponsoring us to make us do fun stuff like this. And now we have guests.
We do have guests.
Yeah, welcome Brian and Jorge.
Guests.
Good morning. Good evening. Good evening in Swedish time, I guess. Good morning at West Coast time. Good evening. Good evening in Swedish time. How are you doing? Good morning. Oh man, we got the echoes. What's happening?
Sorry, that was me.
Technical
That's
difficulties.
always fun.
From technologists.
Yeah.
Yeah.
So how are you?
I'm fantastic. It's snowing here.
Oh,
which is,
is that usual?
I'm in the mountains and it is February, so that's not too unusual. It's been a warm winter. We're in La Nina. But what's interesting is it's starting to snow in Portland, just down the road, and Portland loses its mind when snow. Yeah, I'm sure you guys have seen the videos of like buses crashing into cars and cars crashing into buildings and people falling and slipping down hills. That's Portland because they lose their mind.
Sounds a little bit similar to parts of Sweden. Not all of Sweden. Some are well equipped, some are not.
But that's the same every year. Oh, leaf on the track. We can't handle that. Snow on the track. Oh, it's sunny and then it's too warm. It's always a problem.
Yeah.
And for some reason, nobody remembers it from the last season. Like, again?
Yeah, that's right.
The snow?
What is this white stuff? Do I have to slow down? Yeah. It feels slippery. Yeah.
It's also here in Vancouver. I'm in Vancouver, Canada, and the little tiny speck of snow coming down. Everybody just throwing salt everywhere, and madness in the city. Oh God. Yeah.
It's fun. It's always fun to see how different parts of the world handles weather differently.
Oh,
definitely. I mean, as soon as it's over 25 degrees Celsius, we melt. Well, everybody except you.
Yeah.
But then we have parts of the country that thinks that 25 degrees Celsius is very cold.
Yeah, I agree.
And then we're like, what's that mean? 25 degrees Celsius? I thought that C meant Canadian.
What's that, 80?
That's
Around
25,
80, I think.
25 degrees Canadian.
Yeah.
Canadian, yeah, exactly.
Canadian.
Jorge understands. I think it's like 80 or something.
I have the Fahrenheit Celsius conversion.
Same here.
I
can't handle that. Like half and minus 32 and some. Yeah.
So apparently we are not heard as loud as the guys.
Uh-oh.
They want us louder?
They want us louder. That's a first.
That's a first. So let's see if we can do that in here, perhaps. Let's try and do something like that. Is that better, chat room?
Maybe I need to not talk as loud. I'll just talk like this.
I don't think so. I don't think so.
Can go up a little bit more, maybe.
There we go.
How cool is it though that like we're in a pandemic and that sucks and whatnot, but like this idea that we've sort of moved to online things like this. I mean, this is pretty cool that you folks you're in what, Malmo or something, and I don't know where you're at, somewhere in Sweden. I'm in Portland in the mountains. Jorge's in Canada. It's pretty cool that we get to come together like this.
Yeah, we're in Stockholm.
Stockholm,
little bit further north.
Okay.
Not that far, but still.
Nice.
Malmö is my hometown though, and Mojan56 in the chat is also from Malmö. She's there now.
Oh.
That's actually my mom.
And I believe that was the first time we met Brian as well.
Yeah, it was.
In Malmö.
Oh, we have more people from Stockholm as well. That's cool. Yeah, it's fun that we actually can do something even though we're quite isolated, everybody.
Yeah.
Anyway.
Yeah,
so.
it's also kind of like we need to have like yesterday we had a meetup, and normally when we would do is we go to these meetups physically, we show these devices, we hand each one to some of them so they can walk through. Fortunately, pandemic, happened, so we're doing it all online now. So at least the very least was we could do a single meetup for all the folks across all our meetups. We have a meetup in Portland, we have in Bay Area, in Seattle, and Vancouver. So all those people got to join together, and they follow and enjoyed a nice presentation. So yeah.
I do miss traveling though, man. I can't wait to get back to Sweden.
Yeah.
I gotta say.
You miss the meatballs, don't you?
Yes, Magnus's meatballs.
Yeah.
The knäckebröd and Gotland's blå, the cheese, prostost. And, oh man, I'm getting hungry now. I'm thinking that's
you're fluent in Swedish. Well, at least Swedish food. That's awesome. And you actually have one of the devices.
I do.
Jag tänker om ost.
Oh, there you go.
Oh, you like cheese. Yeah, there you go. There you go. That's nice. So, want to dig deeper?
Yes, please.
Do you want to take it away?
Should I share your screen, Brian?
Absolutely. Yeah, for sure.
Awesome.
Cool. Well, first of all, I think I can speak for both Jorge and I. We're super excited to be here today and speaking to the Swedes. Definitely, like as I said, I miss traveling, and I cannot wait to get back to Sweden. I know they canceled OrDev this year, which was kind of a bummer, but I definitely want to get back and see everyone in person. And like I said, eat all the tasty cheese.
Any year now.
Right, exactly. But enough of that. So today we're going to talk about, building embedded IoT with Meadow, and I drug Jorge along, and he's going to show us something simple, but something pretty awesome and powerful that you can build yourself with a hack kit that we sell, and it's a weather station that both reads internal climate information from an analog temp sensor, and then also goes out to the Open Weather API, pulls it down over using HTTP client over the web, and then displays some graphics and whatnot. So that'll be cool. And as it says, using .NET skills you already have. The magic of what we're going to talk about today is that you can, you really can do all this stuff in .NET now, and it's it's pretty cool. So yeah, and that's where if you want to jump ahead, you can go find this stuff there. But anyway, what I want to talk about is kind of like in a broader sense about IoT and about embedded computing, because we're undergoing a big change right now in what's happening in technology and what we're working on, what we're talking about and whatnot. And it's been interesting because already we're in this like new epoch. We're in this new phase of computing where embedded, this idea that you can put a computer everywhere, is like this new phase of technology, and in my life, I've seen a bunch of these, epics, and I've been in technology and at the tip of the spear working on these things for a long time. And I've seen, I wasn't around. I've never done mainframe stuff. I'm not a COBOL person, I will say, but in my life, I have seen several other big transitions. When I first started, desktop was what we all worked on. It was all about desktop computing, and then the web hit, and that was a major shift in our frameworks and our technology and the things that we built and the things that we could build and our interaction with the world. And that really changed things drastically. And of course, the web sort of like expanded into the cloud, and then mobile hit, and that was like a massive change, right? I remember 10, 11, 12 years ago, whatever it was, and Steve Jobs, stood on stage, and he had this beautiful piece of glass, and it was just like he was touching it, and it was magical, it was cinematic and stuff. And that really ushered in a new era of computing. And I remember going around at the beginning of Xamarin. We didn't have it was before we had dev advocacy folks and whatnot. So I would go out and I would do dev advocacy. And I remember telling people, listen, if you're not paying attention to mobile, you're not paying attention. because it is the thing that's going to be talking, right? I mean, I don't know if you guys remember, but like when mobile first hit, you know, there was a gold rush, but before the gold rush happened, people were kind of like, well, I don't know if I want to get an iPhone. I don't think I need that. You know, like do you remember folks being like, oh, I don't need a smartphone. I got my flip phone. That's all I need. But now, like we can't even interact with the world without having this. You know, we're tied to this pocket supercomputer, and it's interesting because we're undergoing this new shift as well, in which now a lot of folks are building and spending money on and doing things in the embedded and IoT world. And in fact, what's interesting here is that this total spend on IoT today is already 3 times as big as mobile. And in just a few years, there's going to be 10 times as many non-mobile connected devices on the planet as human beings. So for every human on the planet, there will be 10 embedded connected devices. And that really is going to mean a big, big difference. You know, that means that our lives,
insane.
Right? Right?
But then again, everything is connected. I mean, our water heater, our tea kettle, our everything except our juicer is connected.
Yeah, we need a connected user.
Yeah, I think so.
I'm going to write that down.
They tried to do that.
What kind of devices are we talking about?
I recently
what kind of devices are we talking about?
Yeah, I recently changed into internet service provider, so I changed the router. I didn't realize how many devices they were connected to my network. I was like, oh, my phone, my laptop, and then oh my god, my smart lights, my smart plugs to turn on things, and you know other devices. So in the end, I have a list of 30 devices connected on network. Like you never realize until you change your router and you have to put everything, set it up. Yeah, it's pretty insane.
Yeah. Yeah, we had a power outage, and all of a sudden, without internet, we could not not one single light we could use. Well, we had a flashlight somewhere, but that's about it.
So step 1, push up the breaker. Step 2, start internet. Step 3, turn on the lights.
Yeah, that's right. You know, and it's funny. I'm trying to find. Here it is. I've got this. I'm going to drop this slide in on the fly because I think it's actually important. So you asked, you know, what kind of devices are we going to see? And what's interesting is that if I look out and I'm standing in my lab here and I've got a window and I'm looking outside and I see my garden, right? And I kind of look around in my lab. And if I think about in 5 years' time, what kind of devices will be in my, you know, in sort of my home arena here. It's interesting because in a few years, you won't really be able to buy a device that isn't connected in some ways. And a lot of the things that we can do now by putting a device anywhere means that a lot of things that can be connected will be connected. And so I look outside and I have honeybees, right? And this is actually something I'm building today. I'm building a honeybee hive monitor. And so what it does is it records temperature and noise and activity inside the hive. It also records, you know, you can put it on a scale and it records the and broadcasts the weight of the hive, right? So I'll be able to know when it's time to harvest honey because the weight, you know, like the weight of the hive will have hit some threshold, right? And I could apply a little bit of AI, which is pretty easy today. I could apply a little AI and it could actually start to understand different events in the hives and let me know if the murder hornets come, you know, if the murder hornets come. Start wiping out my hive. I could get out there with the flamethrower or the bat. I don't know. I don't know what you do with murder hornets, but you know, like looking around and you know, like sprinkler systems and stuff and whatnot. But what's interesting about this is, and this is why I dropped in this. I dropped in this slide. This is actually from our investor deck. But those types of connected devices, consumer, we call it. So there's three big segments in the connected space, in the connected market. There's consumer IoT, which is like the stuff that we talked about. There's, you know, smart ovens and fridges and all the stuff in your home that, you know, that you might buy at Best Buy or whatever, and you have in Sweden the equivalent. And that is actually the smallest segment of the market. By far, the market is dominated actually by industrial IoT, and also to a smaller extent commercial IoT. And commercial IoT are things like smart buildings and med tech and retail and whatnot. And so you could imagine asset tracking and all the things that you would do in medical technology that would be connected, et cetera. So that's like commercial. But the big sector, and this is where a lot of the money is being spent today, is industrial IoT. And that's stuff like transport and manufacturing, infrastructure, logistics. So we're talking about like energy stuff, ag tech. Imagine here's a sample IoT device that if you go and build this, I guarantee you will become a millionaire. So if you were to build a logistics tracker, and you could do this on Meadow, that you could stick on the side of a shipping container that had, maybe there was a hole in the container, had some sensor for monitoring the atmosphere in there, temperature, humidity, et cetera, or maybe talked via Bluetooth to some sensors in there, and then had a GPS on it and was battery and solar power. And you were able to, like, at any time track in real time that container. So millions of containers go missing every year in the world. And if a container gets misplaced for just a few days, depending on, and that happens all the time in port, right? So there's all these containers that stacked around. No one knows what the hell's going on and what containers where. Imagine if you could know exactly where everything was. And if you went up to a container and you didn't know what was in it, and you had a little e-ink screen, and you took your phone and you scan the QR code on the e-ink screen, and that device, that embedded device, served up a web page with a manifest of what's in there, the like data on like the condition of the contents and where it's going, etc. You would make piles and piles of money. In fact, we know of folks that are actually working on this today. But that's really interesting, because some cargo, like bananas, you're shipping bananas. If that gets misplaced for a few days, those bananas can spoil, right? Yeah. So anyway, this is so when you say what kind of devices, what's interesting here is that we can only kind of imagine. It's like at the beginning of the mobile revolution, we had some ideas of what people would build and whatnot, but we can, like, our imagination it pales in comparison to the millions of folks that are out there that are going to build this and come up with things and think about solutions to problems and whatnot. So the sky is sort of the limit, and we don't even know what people are going to build, and that's the magic, right? But we do know that people are building a lot today, and a lot's being spent in these arenas.
I can't get over. I mean, I misplaced my phone, I misplaced my keys, my wallet. How do you go into your boss's office and say, so, that container, that big thing, I don't know where I put that. Could you help me look?
And it's right. So often. And they also go around the world. There was this, I can't recall the name, but there was this a documentary about, I think it was clothing, that some of the items on your clothing goes 7 trips around the world to make it, and nobody knows why or how. Yeah, so apparently there's money to be made because there's some sort of Bermuda Triangle out there for this kind of thing.
People are just, I should have unloaded that one when it was here. I see, I get it now. 7 times.
Yeah.
It's true, man. Supply chain is crazy. It is crazy, and there's so many opportunities to optimize there, and that's like just one piece of what's available here in the opportunity of IoT. That folks are tackling for sure. The thing about this is, like I said, is that this will actually change our lives. This is going to change how we interact with the world. I mean, think about the difference in time before Google Maps and after Google Maps. You know, think about like even navigating around town or going someplace before Google Maps and after Google Maps. Well, that is the kind of impact. Right. I know my wife couldn't even. There's no way. She like there's a map doesn't even like paper map or whatever direction. If it's not on Google Maps, she's not getting there. That's for sure.
Yeah, that's me.
That's also why she doesn't
even
use Apple
find my
Maps.
house without it.
That's right. No, really. I mean, it's becoming such an extension, such an important and integral part of our lives. And we'll see that IoT will have a similar effect. And this is because, you know, we're moving from a world in which, you know, this was back in the 80s or 70s. This was Bill Gates's vision, was that a computer on every desk in every home, right? Well, we're actually moving into a world where we can literally put a computer in nearly everything, everywhere. And that is the magic of embedded. And that really will spur a very big shift in like how we interact with the world. Again, I recall navigating before and after Google Maps. And so what this means is that the world around us is going to become interactive, right? And so, and this is a powerful thing, because it's not just a lot of folks today, they think about IoT and they think about sensors and they think about data coming in. And that's the first step of this revolution. But imagine not just having data come in, but being able to be powerful in the world around you, in the sense that not only can you get data, but you can actually make changes and you can do things without, you know, in a touchless way, and in a touchless way everywhere. And that, you know, it's hard to overstate just how different the world will be in 10 years because of that. But with that said, this is an interesting revolution, because unlike the mobile revolution, which had this beautiful, you know, hero experience where we had a device in our hand that changed our lives, IoT is a little bit different. IoT is like the quiet revolution that's happening all around us, right? And so even though it's bigger, even though there's more devices, even though there's more things happening, we'll sort of experience it experientially from our perspective will be a little bit different than it was in the mobile revolution.
Yeah, and I mean, a smart home, we were talking about smart lightings and stuff like that. Why should I even have to tell the lamp that it should turn on when it's dark outside and stuff like that? So if I don't notice, it will just turn on and everything works. I will be fine with that. So I think we can maybe have really smart homes.
That's right. Imagine the difference. So pre-remote control on the TV and post-remote control on the TV, right? And I like to think about these things in these sort of like these transitions that cause cultural shifts. So for most of us, you know, for Jorge, I'm sure he's never used a TV that didn't have remote control, you know, like he's young enough. But like for us, I recall as a kid, I remember going up and changing the channel and doing that. But like people today don't even have that context. It's just changed. And imagine a generation of folks who interact with their houses in a way in which they'd never touch a light switch. You'll rarely interact with light switches, etc. What if the house is a living thing that is just around you and has learned your habits and is just does what it needs to do based on your habits, your behavior, or maybe your voice input, right? That's a transition that's happening today. And in 10 years, 15 years, maybe there will be people, maybe there will be, you know, young adults that really don't have that experience, that their experience in with buildings and whatnot is one in which it just sort of, it's there and it does a thing and they don't think about it.
Yeah. Another example was the Google Nest, that smart thermostat. I think it's another kind of thing that it's making our homes smarter. This Nest is capable of monitoring the temperature in our rooms, and based on the patterns of how often we're there, it already starts to notice, oh, he's coming from work, I should start heating up the house for once he gets home. He already, you know, or it's the weekend, so he might stay late, he might wake up later, so I'm going to keep the heat a little bit going in this day. So yeah, the revolution like of smart things is definitely happening right now.
Yeah, that's really cool.
We have a customer that's building something right now that I think is interesting. It's smart windows, and the idea with these smart windows is that they would automatically open and close for passive heating and cooling, and they have little rain fingers. There's a sensor on the outside sill, and if it started raining, then the windows would automatically close, and you could go, you go over your house panel or whatever, you could turn them on, or you could talk to Alexa and say, hey, open up living room windows or whatever. Maybe you could control them with your phone or whatever. There's a button on the window if you want to do like the manual way. But like that stuff is happening all around us, and that, it's not any one thing. It's really like a culmination of a lot of those projects that are all being built right now that will have an overwhelming effect and change how we, really how we interact with the world.
Yeah. Yeah, that's really cool. There's a trend on TikTok right now where you should ask someone who is older than 30 to take a picture. So
to gesture.
Yeah, so do a gesture like you were taking a picture, and they would go like this, right? That's the universal camera gesture. But if you're under 30, they're going to go like this because they're used to do it on the phone. And that speaks to what you're saying with the remote control. I mean, these under 30 might never have seen a camera.
Yeah.
In that.
Or a remote control for TV without a remote.
I have to use my hands to change channel.
Yeah.
It's funny, the save icon on every software,
yes.
It's a floppy disk. After all this time, we haven't seen a floppy disk in how long, like decades. So and now even millennials right now, they were like, what is this icon? Why is it save referred to that little square? What is that thing? And we're like,
yeah.
Yeah.
Totally funny, man. Totally funny. So things are going to change, and I think that this is, there's, because of that, this is a time in which there's really no better time to start learning, right? Because we are in this transition, and on the jobs of the future, the development jobs of the future, if you want to keep at the top of your game and keep at the peak compensation and salary and whatnot, you do need to be upskilling on things and keeping ahead and at least keeping with the times. And so this is just a great time to start learning in how to do embedded. And I want to do just a little bit of context here, because I talk about embedded and I talk about IoT, and we think about, so what is IoT? Well, IoT is the idea that things can be connected, that things can be smart and interactive and whatnot. It's the Internet of Things, right? That implies some sort of connectivity. But what a lot of folks don't realize is that this really 95% of all IoT cases are actually best served by a class of computing called microcontrollers. And microcontrollers are really interesting, and I think it's worth talking about just diving a little bit into what a microcontroller is for those that are unfamiliar, because we've been, as developers and as coders and as folks that have worked in technology for a long time, microcontrollers might be new. I mean, if you think about the things that we've coded on, we've coded for desktops and laptops, traditional computers, and then the mobile came out, and we coded on mobile, and that was a difference. Like we had to learn iOS, we had to learn Android, but that was still like kind of this really powerful processing platform, and IoT and embedded is a little bit different. IoT is overwhelmingly powered by these things, like I said, called microcontrollers, and a microcontroller is something that's really interesting and very unique in the spectrum of computing. So think about a microcontroller is like a computer on a single chip, but it's not just that, it's also built to control hardware. So if you look at for example, if you look at our the F7 dev board, which is our flagship embedded module, in the middle of that, you'll see there's an F7 microcontroller. And then there's also a coprocessor, which is another microcontroller, an ESP32, which gives us Wi-Fi and Bluetooth. But that F7, that chip in the middle there, is basically a Pentium, but it also has a whole bunch of I/O to control hardware in the world. And I'm going to talk about that in a second. But microcontrollers are interesting for a number of reasons, and they're distinct from other classes of computing for a number of other reasons as well. And we think about the first kind of commercially available microcontroller actually came out in 1971, and so that was almost 50 years ago, or is 50 years ago. It is literally 50 years ago. So that was 50 years ago, but like, why are we talking about them today, or why are they so important today? And something has happened. The mobile revolution really changed the game for embedded hardware, right? So mobile phones gave us a whole new class of low power, commodity cheap peripherals like displays and sensors and storage, and also credible batteries and whatnot. But another thing that it gave us is ultra small process for chip manufacturing, for forging chips, and really, while the latest generation of microcontrollers, of 32-bit microcontrollers, have been around for a while, it wasn't until the last few years that they really came into their own. And what's interesting about, to be clear, a microcontroller is not, they're not a CPU. It's not an app processor. They're absolutely everywhere. There's trillions of them in existence. Last year, 30 billion of them, over 30 billion of them were shipped. And the thing about a microcontroller to think, in terms of their difference between that and other classes of computing, is that microcontrollers are not full. They're not like full computers in the sense that they don't run a big, heavy OS. They don't run Linux. Right. So there's some sort of like variance to that. There's like micro Linux or whatever, which is not what we traditionally have thought about in terms of an OS. It's not something that has multiple users and multiple applications, in which the OS is actually the heaviest thing, that in terms of processing, that's the heaviest thing that's happening. It's just the opposite with microcontrollers. They run micro real-time operating system, or micro RTOSes, and those. This is really interesting because those operating systems, the size of those are generally measured in kilobytes rather than, megabytes or really gigabytes, right? How many gigabytes is Windows today? I don't know. It's like 10, 50. It's enormous, right? A lot. It's very big. You don't have anything like that on a microcontroller. A microcontroller it runs just enough operating system to expose hardware and run a single app. And your app is really the meat of the processing on a microcontroller. And that's really a major difference to that. And there's some upshots. There's some byproducts of that scenario. So the first thing about that is, because you don't have an operating system sitting there and churning and doing a lot of other things and whatnot, it's really about your little app. Then microcontrollers are often ultra low energy. And when I say that, I mean you can build apps on microcontrollers that run on coin cell batteries, and they can run for a long time. You can bring them up, do a little bit of processing, squirt a little data to the cloud, and then go back to sleep. And you can do this for months at a time on microcontrollers. They literally use 1,000th of the power generally than something like a Raspberry Pi. And we actually see that the Raspberry Pi Foundation is now like jumping into microcontrollers because of this, right? So what happens today is that a lot of folks who are building IoT or embedded, they'll often like prototype first on an up-level platform like a Raspberry Pi. But when it's time to go to production, when it's time to actually put this out in the world, you build again and you rebuild for embedded hardware, and you rewrite your app, you rewrite your code and whatnot. And what's interesting about microcontrollers, or interesting about our platform, which I'll talk about a little bit, is that you don't have to do that anymore. Now you can actually start out, you can build from embedded and from the get-go, and you can go to production that way, right? And as I mentioned, this is all really made possible by the mobile revolution, because it was the mobile revolution that gave us this technology and really like up-leveled microcontrollers. What's interesting today is that, you know, we saw the Raspberry Pi, their new microcontrollers, like $4, right? $4 for the board. And the pioneer of that was really the Espressif ESP32. That was a microcontroller that did Wi-Fi, Bluetooth, had dual core, and ultra low energy, and it was like $3, $4 chip, you know, and that is a major, like that's a major diversion from anything above it in terms of the computing platform, because we think about like, well, you might be able to embed a RPi 0 or whatever for X amount of dollars, but it turns out like the actual cost of putting that into solutions winds up being much, much higher, because there's a bunch of external componentry and other things that you have to actually build, you have to add to control hardware and whatnot, whereas microcontrollers already do that. And so you wind up not only saving a bunch in terms of power and energy consumption, but also in price. So microcontrollers, very different space. And I want to, you know, we're going to talk about, Jorge's going to show us a little bit today about what we've got going on. So we, you know, our platform, but I just want to introduce kind of what we've been up to. And we've created this, we've created a developer platform that runs on microcontrollers that's called Meadow. And the idea behind Meadow is that we set out to make embedded development as fast and easy as mobile or web development, which is a big lift, because if you look actually in the industry, if you're building embedded today, there's sort of two paths you take. 95% of all professional embedded development today is done in embedded C. So embedded C is a very like low level language. It's a very specialized skill set. You have to know a lot about, or you have to learn a lot about embedded hardware. And there's a lot of bit twiddling, and it's fighting with CMake or whatever. It's a nightmare. But that's if you want to do professional apps, that's generally how they're done. There's another thing that's happening in the industry, which is also interesting and is very cool. And it's like MicroPython. And MicroPython sits on the other end of the spectrum. It's incredibly easy to get started, but it doesn't, it's not professional like embedded C. It's not fast. You know, very few things are actually going out to production in MicroPython, because it's more of like a learning toy. You know, it's a good way to get started, but generally you're going to have to switch over to embedded C at some point. So what we set out to do was bridge this gap and give the best of both worlds. And as we know, .NET is the coolest platform on the planet. So
well, I don't think he will get any arguments from us.
Honestly, I mean, I love .NET. I've been in this industry almost 30 years, and I've dabbled in nearly every language that, you know, that is mainstream that's come out. And I still love C#, and F# is so cool. And, you know, the fact that you can just run it everywhere and share code and stuff. And there's this massive ecosystem, and man, .NET Core is small and fast, and it's cool. I love .NET. Anyway, so we brought .NET to the embedded space, and we enable you to run full .NET applications on embedded devices, on microcontrollers. And we did that. It was not easy. We've spent the last 4.5 years building this, and basically what we've done is that we've taken a micro RTOS, we've taken NutX, which is probably hands down the best micro RTOS kernel around. It's really the engineering on the kernel is incredible. And what we've done on top of that is we've taken the mono runtime, and we've done a bunch of plumbing, and we've gotten that working in the context of NutX. And then we've built a bunch of APIs for hardware that are like .NET centric. We've thought about these APIs and exposing them in a .NET way, and in like really ways that would be familiar to .NET developers as opposed to like embedded C developers or whatnot. And then we've built on top of this, we've built a peripheral and driver library called Meadow Foundation. So the idea is that you can go and grab peripherals or things off of Adafruit or SparkFun, displays and temp sensors and accelerometers and whatever else. You plug them in and you just have an API and you just go, right? You don't have to do a lot of the low-level coding. You don't have to do plumbing stuff. And that is, and that's what we've built. We basically enabled .NET developers now, we've brought .NET to a new computing form factor, a new class of compute to unlock embedded IoT for the rest of us. And we have a fantastic piece of hardware. It's really state of the art. This is our F7 platform, which comes in two form factors. It comes in a developer board, as you see there, and then it also has an SMT module, so you can actually go from prototype to development on the same code and the same hardware. So you build here your first 1,000 or 10,000 products that you ship, maybe have this, and then you start to you switch over to the embedded module, and we have exposed basically everything that you need to do hardware. And I mentioned, the chip that powers this whole thing is basically a Pentium. In terms of the number of transistors or computing power, MIPS, however you want to shake it down, it's roughly, you can think about as a Pentium class computing, but it's also got a whole bunch of the chip that's dedicated to hardware. And when I say hardware, there's a lot of different ways to communicate and to control hardware. So there's like the basic stuff, which is we call GPIO, and that's a digital port that you can raise high or low, and you can turn things on, you can turn things off. But built on top of that is also a bunch of protocols for speaking to different peripherals. There's I2C, which is like a serial protocol where you can put a bunch of devices on a bus, and you can address them, and you can talk to them, and it's very cool. SPI is a very similar protocol, but you can talk very fast, so you can drive displays. UART is things like our old serial stuff. Like if you're dealing with GPS receivers, you might talk over UART serial. CAN is it used to be actually car area network. It's now controller area network. They've renamed it because it's used in more places than cars. And then one of the other things that are interesting, analog. So analog I/O, being able to read analog, like Jorge is going to show us today, reading an analog temp sensor, which gives us a voltage reading somewhere between like 0 and 3.3. But instead of being just digital high or low, it might give us like 1.6. And so it's, I don't know how many degrees Canadian that is, but and then of course, motors are controlled by PWM, which is a digital signal that emulates an analog signal. So you turn on and off real fast, and depending on how often you're on, the duty cycle, how much of the time you're on, that actually gives an output of some averaged voltage, and that's how you drive motors. So with this, you can do basically anything. You can drive motors, you can drive displays, you can listen to sensors. And because it has Wi-Fi and Bluetooth, you can connect to the internet, you can connect to devices, locally. And it's got some other cool stuff on there as well. Like, as it mentions here, it's got 2D graphics. So we're working on bringing an accelerated graphics UI library to it. So you can drive touch screens, and it also has a bunch of built-in security stuff. And of course, floating point stuff is really fast. So very, very interesting hardware.
Yeah. It also contains an integrated charging circuit, correct, Brian?
That's right. So you can plug in a battery and a solar panel, and that's it. You don't have to do anything else. Like you can just power off a solar and battery. Like for my Beehive monitoring station, I've got a battery. It's just a little it looks like this. So 2200 milliamp lithium ion battery. I plug that in, and it just literally plugs into the Meadow. And whenever you're powering the Meadow, it will also charge the battery. So that's built in, and that's quite nice, because we know a lot of IoT is placed in places where power is at a premium. Maybe you have solar, or maybe you have energy harvesting or whatnot. So we've got that built in.
Yeah, another feature that I really enjoy is that I really like is the watchdogs. It's this piece of logic or feature that if you're running an application and say you have it somewhere in the wilderness and you have a camera or something, and for some reason starts to fail, the watchdog able to detect that the app has crashed, so it'll reset the board and restart the application. So you no longer have to go and climb the tree and try to bring your laptop and deploy and anything like that. You just do it. It'll just do it automatically. It's like a plan B contingency logic that the board is including. So it's pretty cool.
That's right.
It sounds like you thought of everything.
Yeah, a little bit.
Hopefully we thought of a lot of it. Yeah.
You mentioned that it's running the mono runtime. Is it the mono runtime, or is it some kind of special version that you guys have?
Yes. The answer is complicated. Is the mono runtime, but with a lot of modifications. You know, so yeah. Mono gave us a lot of what we needed to run on ARM. You know, in terms of the instruction sets and stuff, but we did have to do, there's a lot of modifications around the garbage collector and how it manages memory on these devices, which is different than how memory is managed in like your iPhone, for example. So it is, you know, and we've pushed some of that, we've pushed a lot of that stuff back upstream into mono, but it's definitely still, there's a lot of custom stuff here for sure.
So yes.
So now when .NET 5 came out,
that's right.
So now when .NET 5 came out, are you going to use that mono?
Yeah, so we're in the process of actually switching to. So when those changes come out, and .NET 5 is still like partially mono. You know, it's not the. It's still kind of a Frankenstein of. So just stepping back a little bit of context. So what we had was we had the .NET runtime. So the two mainstream runtimes, there's other stuff too. There's like Core RT and whatnot. But you had the .NET runtime, and that was for like Windowsy stuff. And then you had Mono, right? And then Mono was what we used at Xamarin, and Mono and .NET was what folks used on Windows. And those sort of like existed in parallel. And things would happen in the .NET runtime, and then Mono would implement them, and so they keep up to date. And what has happened now is that Microsoft has been taking these two runtimes and they've been merging them, right? Because Mono provides a bunch of stuff that the core .NET stuff never had, right? A lot, you know, this was very Windows. Win32 required it was a lot of p-invoke to Win32 stuff, whereas Mono was Linuxy and could run on ARM processors and stuff. So what's happening internally is that those two runtimes are like being sort of like pieced together into a new thing. And ultimately they think this will be finally merged in like .NET 6-ish. But .NET 5 is like kind of an interim step into that space. And so Mono is still around. Mono still being updated because it provides a lot of stuff that doesn't exist in the .NET runtime, and a lot of those tooling and a lot of the pieces are actually now in .NET 5. So .NET 5 is a chimera of .NET and Mono. So long story short, we're actually in the process of like porting those changes to our platform so that we can be fully, you know, .NET 5 or 6 compliant. Today, we support .NET .NET Framework 4.7.2 and .NET Standard 1.6. So our goal is to be like core compliant, which is, you know, standard 2x. You know, it gets a little bit fuzzy, right? Actually, you know, Microsoft talks, they have some terms to describe these things, but in reality, underneath, it's a little bit fuzzier than that. I mean, the .NET naming, right? Like, what is this? Long story short, we're basically kind of on par with like Xamarin. Xamarin's not .NET Core, .NET 5 yet, but we're like bringing parts into it, and we will get, you know, at some point we'll get all the way up to speed, just like, you know, Xamarin will get up to speed, etc.
Mm-hmm.
Cool.
Yeah. So I think, you know, probably a good time for me to hand it over. Jorge is actually going to give us a demo. He's going to show this in action. He's going to show that Wi-Fi, this Wi-Fi weather station, and then show a little bit of like how to, you know, so to hear something that's kind of sophisticated, you can build a hack it, and then he's going to go and talk about how you can get started. So I will hand the floor over to Mr. Jorge.
Awesome. Thank you, Brian. Let me set up here.
That sounds fun.
Let's do, I'm going to share the screen now. Let me know if you guys can see the screen. There we go.
There we go.
Awesome. All right, cool. My Droid Cam is working this time. It was failing for me last night in the meetup. I'm like double checking this will work this time. I like using my phone as a webcam. It has a better quality. So, all right, let's turn.
So that is actually a device. Yeah. Look at that. It's not a picture of a device.
It's an old Pixel phone that I had, so I like to use it as a webcam now. But nice. Here we go. Here we have a Meadow device. And we have connected here. Let me turn this on, and while it runs, I explains what's going on here. So we have, this is an ST7789 TFT SPI display. I know it's a long name. It's basically a 240 by 240 LCD display. That's all you have to know for now. And then later on, we'll go into the greater of the details of how to wire it up. And notice that there's a green LED, RGB LED on board here on the board. I'd like to change colors on my apps, so it gives me a feedback in real time of where the app is running, like the same way you would do desktop. You would do console output, and then you'll see those outputs everywhere and see what's happening. And now you can see. There you go. So this is like the final stage of the application I want to show. Notice we have here a little icon for the weather showing the date and time.
It's so cute.
The indoor and outdoor temperature. Yeah, and so the indoor.
Yeah, someone also has to translate for Brian because that's Canadian degrees.
Yeah,
it's all like 21 degrees Canadian. I don't know what that means. But it looks cold outdoor. I can see that. It's minus.
Yeah, I think this is for the first time in over a century that the entire Canada is below freezing point. It's something like
we have this.
That has to be a lie. That has to be a lie. How is that possible?
Vancouver is like the warmest city in Canada. Like people in Calgary, they're mountains of snow, -30. I'm like, oh, look here, we have cherry blossoms already. So it's actually pretty crazy. We're like, oh, no, it's cold now. And people like Calgary are like, really? It's only -0. Like I can go out in t-shirts and shorts and it'll be fine. So, different.
Which our Canadian friend actually does.
Yeah, that's true.
Yeah.
Finally living up to your name of the Great White North.
Yeah.
It took 100 years, but we knew you could do it.
Yeah, so yeah, this is a project. I think it took me maybe a couple days to put it together. I wanted to get really nice the UI and nail down, so I use a different software to do a little square 240 by 240 and start doing some math. And I finally got it to work on the Meadow device. We have a graphics library that helps you how to do these things. I'll show you in a second. And over here is an analog temperature sensor, which is this little guy who looks like a transistor. But let's just dive into code a little bit. I'll give you a big overview of what the application does, and then I'll show you a little file new project experience for the new folks that want to get on starting with Meadow. So, so right now this is the project. It's called Wi-Fi Weather, and notice we have. This is Visual Studio, man. This is what we love. This is like C#, .NET, all good things. So we have here some files here. These are little JPEG icons that I include. So you can see with the graphics library, able to even draw JPEG images into our display, which is really cool. And notice, well, we have certain things here. We are connecting to now, as Brian mentioned at the beginning, we're connecting to a public web service for weather. It's called the Open Weather Map, and it basically gives you real-time data based on the city or whatever different parameters you can send it, and it'll return you a JSON string with a lot of information. So you can check here the weather reading, for example. You can see all this data that is returning. I'm just showing the tip of the iceberg, which is just the date and time and the temperature. But you can do a lot of more things. Like there's a lot of potential here to have a menu so you can interact and change other to show even more data. But Okay, so this is.
Could you enlarge the font a little bit?
Sure, of course. Let's see. So
what's cool there is that when I'm looking at that weather service, it looks a lot like just standard C#, and not just standard, but like up-level stuff. You know, we've got task, we've got threading, you know, we've got all of the stuff that we love about writing modern C# code.
Exactly. So I think that the big takeaway of this project, the core, is here you go. You have an HTTP client. That's something that, you know, you would use on your desktop phone. You can use on your phone. You can use a desktop. These things are very familiar to us, and we can run it on microcontroller, which is pretty awesome. We also do. We can use system text JSON NuGet package as well. We can add NuGet packages from the gallery, and we can add them and run them into our device, which is also pretty exciting. So basically, when I get the response from that GET request, here we go. I just do system text.json and start deserializing all the data. And now I have all the data in my proper model, and I send all that information to my display controller. Again, I don't want to dive in too much, but I just want to show you how complex you can go on these applications. But this other class is also really interesting, because here's what I showed you, how when you initialize a display, this is the code to just initialize it. This is just what you need. You need to specify to which pins you are connected. You are connecting your display onto Meadow, and you give a certain field of parameters, like, well, you know, this display is 240 by 240. The type of bus of communication that you're going to communicate with, in this case in an SPI. We'll dig into that maybe a little later, or we have also great official docs that will explain in detail how everything works. But the takeaway here is we have a graphic.
That's a driver that's already there. Like, we don't have to, if you're an app developer, you don't have to go and write a driver for this display. Like, literally, Meadow Foundation, that driver is there for the display. The driver is there for that analog temp sensor. The driver is there for just about anything you want.
Exactly. And here enters Meadow Foundation, which I like to think of it as the Xamarin Forms analogous for hardware. Xamarin Forms, as you may know, is a cross-platform framework to make applications for Android, iOS, Windows, and they're all falling onto the same code base. We want to do that with hardware as well. We want to try to abstract our hardware developers to get their solutions working and spend less time trying to figure out their components that they want to use. So Meadow Foundation has a stack of over 100 different peripherals that are ready to use, and you just need to look them up. You add them as NuGet packages, and you can start using them right away. So one of them that is also really interesting is the graphics library. It's a Meadow Foundation in-house graphics library, as well as the name suggests. And you pass in your display object. You pass it in when newing up a graphics library, and now you're all set, because graphics library is agnostic to the type of display that you're running with. So you can run it on an LED display or an OLED. You can do an LCD. I have this little matrix, dot matrix, an LED dot matrix display here that I've been working on, and you can run graphics library on this as well. So it's a really powerful library, and already gives you a set of APIs to do things like draw text, for example. You got a graphics draw text. You can do display JPEG, so you can load the resources, and you can use a decoder and start drawing images onto the display. All sorts of fun stuff. You can do circles. You can draw circles, rectangles, in different colors. Graphics library is just awesome to work with to make engaging UIs and displays. But I just want to jump now into basic getting started project. So I'm going to take this one out of here. And
by the way, you can
while
build
you do that.
today, we have a hack kit that has all the parts that you need to build this up on our store, which is store.wildernesslabs.co. So you can get that hack kit, and that has the analog temp sensor in there. It's got that display. It's got buttons. It's got a whole bunch of stuff in there.
Correct. Yes. And every day, like as a developer advocate for Wilderness Labs, my job is to try to make really nice, engaging projects with Hackster that involves with HackKit most of the time, so people have more chances or see the possibilities to make these projects. But I think I can show you real quick a little gallery here before I continue. I have it open here already. So if you go here to my profile, Jorge Devs, you can see already the big, let me move this for a second. You can see over 40 projects of Meadow with different devices here. And you have all sorts of different things. Here's the weather station that I showed you just now. You can make a Wi-Fi connected clock. So there's another public API that you can just call, do a GET request. It returns you the time based on the city that you're in. You can do Tetris, memory games. Last night we showed the LED strip. There's an LED strip you can drive, so you can write your own set of different patterns and make it blink depending on certain or whatever. You can even put a temperature sensor there and make it blink depending on the temperature of the room. All sorts of different things. So you can see here is just the tip of the iceberg. There's a lot of information here, a lot of cool projects that you can get started and get familiar with all this. But let's jump ahead and let's go back to the getting started. I know, I think Jimmy really wanted us to take a look at that because I think it's really important. Let me close this solution.
Let me show the store link as well. I actually happened to get a little bit teared-eyed when you talked about the display, how that is beautiful.
Yeah, thank you. Yeah.
That's amazing.
Yeah, and it's just very interesting. We are working on other projects, and graphics library is just super awesome to make display engaging UI like that. We also have a framework for text display menu, so you can generate menus based on a JSON file, and it's just super easy to use. And you can use different buttons, or you can use a rotary encoder to navigate. Again, I can just stay here all day explaining all the different things that we have. But let's jump back to the getting started experience. So you would need a Meadow VS Tools extension that you'll need to connect Visual Studio to Meadow. I have it already pre-installed. So say if I look for Meadow in the project templates, let's wait a bit. My computer is falling asleep now.
It's that time of day.
I know, right?
Siesta time. It's thinking about lunch.
Yeah. Oh, I don't know what happened, but it jumped.
Lunch? We already had dinner.
Maybe it's going to go get some pepper taco order or something.
Yeah. Oh, there we go. Okay, finally. All right. So right now we currently have 4 different template projects. So you can use C# and F# projects as well. And we have templates for even Visual Basic coming down the line. So for all the people who are into the .NET world, they can use all these different languages. And let's choose C# because I think we're all the C# people here. And let's click next here.
Please do.
Now let's call this project Coding After Work. And then let's do create.
So let's see if this is as easy as he says.
So yeah, we want to keep it as simple as possible. So right now you can see off the bat, we have 2 class files in our project, in our new project. And one is basically the standard program public static void main method. And that one will be the one who will call the application that is actually where the meat of the app, of the Meadow app, it's at. So this is the Meadow app class. And notice right off the bat, we have two methods here. And one very important is the initialize method. Is normally we're trying to design a pattern for all the users of how to make Meadow applications. So we normally want to encourage people to have an initialize method. And here's where we're going to set up all the peripherals that we have connected to Meadow. In this case, we have a class, thanks to Meadow Foundation, which is already included in the project. And a Meadow Foundation core NuGet package already has a set of very common peripherals. So in this case, we have an RGB LED driver, and this one we're setting it to the onboard LED pins that the Meadow has. So we're already setting up an object with an RGB LED that is the one that is connected to the pins on the board. And after that, we call a cycle color method. And what this will do is just showing a pulse animation for each, for this list of colors that you see here. And it's enclosed in a while true, so it'll stay going on forever until the power runs out. So let's just run it.
Till the sun expands and consumes us.
Yeah. So this is the Meadow Device Explorer. That's something that comes in the Meadow extension, and we needed to control. Here we go. Where's my output? Here's my output again. Oops. Okay, so here is my Meadow Device Explorer. Is something that we need. And where is my output? What's going on here? Okay.
Getting crazy.
It's a live demo. That's what's going on.
I know. Okay, so after I plug in my device, which is something that, it's important that we have to do. We plug it in. And now we do refresh device ports. And that will tell us, this will detect on which port on your computer Meadow it's connected to. In this case, is COM3. And now let's build and deploy this bad boy here. Oh, here's my output. Okay, I see it. So the output is also your best friend in this case. Yeah, because it'll tell you what is happening during the deployment process. It's able to tell you which files are already deployed in your device, and it'll see which ones are removing, which ones are adding. And it's smart enough that it'll only deploy or only upload those files that you're changing. So there you go. Now it's already running. You can see that little LED on board blinking and changing colors. But now
and yours is changing colors as well.
Yeah.
There you go. Yeah. So that's the boilerplate. That's a template of what the project brings in store whenever you do a file new create. But let's make things a little bit more interesting now. Let's say we want to put.
See, he's going to make it more interesting than blinking lights.
Unheard of. Unheard of.
So I have.
So we have this little, I don't know, fight. No, it wasn't a fight. But Jimmy came down one day when he had I don't remember what board.
I think it was the Netduino.
The Netduino, yeah. So he came down and he was like, look at this, there's a blinking LED. Like, yeah, I see it's blinking. No, you don't understand. I wrote code to make this blink.
Exactly, yeah. That was also our first eureka when Meadow was first starting. We had to go through, we didn't have this Meadow, this Visual Studio extension or anything like that. We had to go through several terminals, copying files over everywhere, driving instructions, and then when we got that LED, that's where we all yelled eureka in that moment. It was just so inspiring. We had to
have like 3 or 4 other boards that were attached via Frankenstein cables and stuff. We've come so far since.
We've come so far, yeah.
But the LED was blinking.
That's right, now it's blinking. But like now it's so easy and fast. You saw how he hit the button and it was just like up, initializing. I mean, it's really like snappy and really, it's become a real pleasure to develop with.
Yeah. So what you see here, I connected a little simple red LED here. So I just want to show you how easy it is to get this running. I hope it works. This is like a live code demo. I don't normally use this.
No pressure.
Yeah, no pressure, but let's see what happens. So the first thing, like, okay, I connected my LED device here, my LED onto my Meadow. So the first thing I'll need to do is create a field here on my Meadow app class. And look at that, we have an LED driver, and let's just call it LED again, lowercase. And now we go into our initialize method. And let's do LED, and let's just new it up. So to initialize it, again, we need to pass two things. We can either, we need to pass in the device and also the pin, which is the LED is connected, which in this case, it's the pin, the digital pin 2. So we do device dot pins DO2, and that's it. That's all you need. That's all you need to know when initializing an LED, for example. And in this case, we're behind under the hood. We're working with a digital output signal, so it only go from 0 to full-on 3v3. It's recommended that you use a resistor for this, but for demo purposes, I'll just go ahead and just
let's see what we get the magic smoke.
It'll handle it for not that long, but it will work.
We actually have a class called PWM LED that will enable you to drive this with a PWM. Remember, I talked about how PWM pulse width modulation is like on off, and we'll actually with PWM we can actually pull the voltage way down, so it's only so it won't magic smoke the LED. So we've like and after Jorge, after we see this, we'll switch over and we'll show. We have this massive library, really. Like Meadow Foundation is enormous. There's like over 120 something drivers for if you go to SparkFun or Adafruit, just about anything that you want to pick up there's probably a driver for it. So you don't have to go and fiddle with driver stuff. It just works.
Correct. Yeah.
So what I'm hearing is that you can use all the stuff you already have, and you don't have to buy new stuff.
No, that was not what he said. He said you should get a hacker kit.
Yes.
Yeah, and then use your old stuff as well.
10 of them. Should get 10. You gotta have extra parts. I mean, plus you want to give them to your friends.
Yeah.
And your moms.
So yeah. So notice what's happening here. We have an LED. We're newing it up, and now the LED has a set of high abstracted API, and there you go. It's starting to blink. And how is it blinking? Well, our Meadow Foundation API have this set of different animations that are pre-built already, so you don't have to write a digital output port and write your own method to make it blink. The Meadow Foundation driver just does it for you. So you have an LED start blink, for example. There's a field is on that whenever you assign it, you can make it turn on and turn off. And we also have the stop method, obviously, to stop any ongoing animations. For this case, it will be the start blink. So yeah, it's all
for PWM LED. We even have other stuff like pulsing, so it could like actually like kind of raise and lower its intensity in like kind of in a nice way. So there's a lot of stuff that we've just like common stuff. We just want to make it dead simple, easy. Like you don't have to think, you don't have to do anything. It just should work,
Exactly.
I just want to say that in their backlog, at some point, they had make a method that will make the LED blink. That was actually something you had in your backlog.
That's right.
I love that.
Yeah, so
that is kind of amazing.
Like to new it up a PWM LED, not only we need to pass in where it's connected, we also have an enum to saying, oh, what color is your LED? Because we can actually optimize the voltage output for that LED. So we no longer need a resistor. So you can see typical 4 voltage, and then we have all these different colors. So in this case, I use red. And the driver is like, okay, got it. So I won't fire it up into 3.3 volts. I'll just go and lower it and just give you the exact of the optimal.
No magic smoke.
Yeah, yeah, like
that's
right.
That's kind of amazing.
Yeah.
Okay. Is there a method that says to release the magic smoke Do you have that?
It's the like server.puke in ASP.NET, right? Server.explode. Meltdown.
Yeah.
Self-destruct.
So you can see here we have now PWM. We can do more things. So we have that the pulsing animation, which is the one that you're already seeing when we first run the app, that it was pulsing different colors on the onboard LED. That's actually what we're doing. We're doing, but we're creating an RGB PWM LED that is running like pulse width modulation signals across an RGB LED to get all those different kinds of hues. So let's about to run here the pulse animation on the LED, and let's just move into the next phase. How am I doing on time, by the way? We have some time left. I think we
have 15 minutes, but we can always go a little bit longer.
There's
if we
lives.
need to.
There's
Let's go
blinking.
to analog sensor action. We're getting party in here.
Yeah. Okay. So there you go. You can see the LED is pulsing a little bit. I think the camera doesn't pick it up as well as you see it live. But you get the idea. The idea is Meadow Foundation. You have your set of peripherals. You tell them to, in the initialize method, to which pins are connected, and then you have already do your object dot, and already has a bunch of APIs that you can use off the bat. So let's elevate this, and let's go next stage. And I'm going to use a little push button here.
Who doesn't like a button?
Yeah, exactly. All right, so I have a push button now, and now what do we do here? We add a push button. And this is another very common peripheral, so it's also already included in the Meadow Foundation core NuGet package. For more specialized ones, you will need to install it as a separate NuGet package, because we can't bring all 100 different drivers and condense them into a single NuGet package. It'll just take away all the memory of the device, and is not optimal. So let's just create a field here for the button, and let's initialize our button here, new push button. And now I pass in the device. In this case, it's Meadow F7. We also need to say on which pin is connected. In this case, is the digital pin 4. And we need to also specify the resistor mode. We need the resistor mode because to connect a push button, there are several ways of you connected. So you need to specify how you have it connected in order to get it to work. So in this case, I have a very nice blog post on push buttons to clarify how, when you're wiring, how is the best way to use it. I'm going to use an internal pull-up resistor.
Pull-ups give a default value. So what it does is like, if you don't have it, so a pull-up is like a strong resistor that allows a little bit of current to flow to the port so that it has a default value. So it'll be at like high or whatever if it's a pull-up. And then and it's very small. It's a very small amount of current so that when you do push the button, then it'll go low. And if you don't have a pull-up, either internal or external, you know, it can basically, it's called floating, and it can pick up noise in the environment. And so you might have a lot of errant like click events or whatever. And so a pull-up is a really common thing in circuits that prevent that by providing just a default value, either high or low. Or later on, the same concept is used to bias things in circuits. So if you have a switch, a transistor or something, you can bias it so that it's not, instead of like, it's kind of like floating in the wind and kind of on and kind of off, you know, like it's off or it's on, you know?
Yeah. So here we go. We have a button field. We initialize it, and we have, you guessed it, we have event handlers. So in this case, we have a click event handler. We have other different type of events. We have long press click. So you press the button for a long time, then you release it, and then it'll trigger an event as a long press. We also have started, press ended or press started. Press started whenever you press it, you leave it pressed. Press ended when the moment that you released it.
So you could write your own, like, you know, recognition, things like that. Eventually what we'll do on there is we'll actually have a little, like a pattern matching recognition framework. So you could like write patterns for different things like this, not just buttons, but like rotary encoders, which have like some sort of signal. You could just write a recognition pattern to know like what's happening with that. So that's something that'll, you know, in the future we'll add. Something similar to like recognition, you know, recognition handlers in iOS or whatever.
Cool. Yeah. So that's it. After the application is running, whenever I press the button, you can see the LED is starting to pulse, basically because I have my button click event handler and is using the LED and just start to pulse. So that's the gist of Meadow Foundation. It's just putting peripherals together, newing it up in the initialize method, and just starting to work with these objects.
Okay, I give up. I'm a little impressed.
And as I said, you know, there's like something like 120 peripheral drivers. If you want to show my screen, I'll show.
Yeah, for sure.
So if you go to developer.wildernesslabs.co and you see this big section on Meadow Foundation, so you can go and check it out. If you click on peripheral driver library, you see that there really are a pile of drivers. And as Jorge mentioned, the way this works is that there's like Meadow Foundation core drivers, which are sort of generalized drivers. And that you know are in the main NuGet package. So the stuff that we saw, PWM LED, RGB, PWM LED. There's also a bunch of other stuff like, you know, general H bridge motor or piezo, you know, buzzer and rotary encoder and switches and relays and things like that. But then there's individual NuGet packages to add specialized drivers, as well as libraries and frameworks. So things like you know, displays, we've got piles and piles of display drivers. And in fact, you see a lot here, but even within there, like we got a broken link. Even within this TFT SPI library, there's like 10 additional TFT display drivers. So there's really everything that you can imagine that you want to drive. So e-paper, here's a pile of those TFT SPI displays, feather wings, various integrated circuit chips, so EEPROMs and IO expanders. So if you need more IO, then add a shift register or add an MCP 23008, you know, and then add 16 more ports or whatever. So that's all just built in. You know,
can you click the LEDs APA 102 so show them in detail how a doc, official API doc looks like?
That's right. So for every one of these, we actually have really great documentation. So here's code example of how to drive it. And then also here's a circuit diagram. So this is how you wire it up. Really, this is plug and play, you know, just plug it in and it works. So, and some of these have links to where you can, you know, even buy them, etc. So there are really piles and piles of drivers, everything that you can ever imagine for like atmospheric sensors, you know, temperature, humidity, pressure, etc. Distance sensor, light sensors.
You weren't kidding. There's a lot.
There is a lot in here. Here, you know, every kind of accelerometer under the moon, you know, is like we've got a driver for that, and power, you know, current sensor drivers, so you can actually see how much juice things are using. We even have a radio drive, you know, like we have RFID and we have an NFC one in progress. Anyway, servos, they're there. It's just piles and piles of stuff. And, you know, definitely if you want to get started, I would say go to the store.wildernesslabs.co, buy one of these hack kits, because it's got, you won't find a better deal. It's got a bunch of really awesome peripherals and things that we have drivers for, and we've curated this. You know, we've tested out these components and we've chosen them, and it really is a great kit, and it'll get you started. And then you know, go to developer.wildernesslabs.co and run through the getting started guide. That'll get you up and running. And also, if you want some inspiration, I know Jorge mentioned this earlier, but on our developer site, scroll down to View More Projects, and this is where you'll find all kinds of stuff that you can build. And the great thing about this is that these are all, it's all like pieces of stuff. You can put them together to make much more sophisticated projects and whatnot. So, definitely don't be shy. Go and jump into this and have a good time.
We also have a very, very reactive, a very engaging audience in our public Slack channel. So whenever somebody is having a problem creating a project, they just put it on the support channel and we'll just jump in and just try to help. Actually, an hour before starting this meetup, I was helping a person trying to get the Wi-Fi weather working. He forgot to set the build action to those files as to deploy them into the application. But other than that, yeah, it's all about helping each other and getting them to have fun while they're working on Meadow things. So
yeah, and Jorge mentioned Slack. To get that, just go to our website, and at the bottom there's a Slack icon, and that will get you access to our Slack.
Yeah.
Awesome.
Now, I was, of course, very excited about this, but I'm even more excited now.
How is that even possible?
I need a vacation or something.
Yes, you can start developing. Well, you got it blinking.
That's true. That's true.
It changes color. But no external LED yet.
No?
No.
Yeah, you'll get there.
You can have one of mine.
You just need to go buy 10 hack kits, and you'll be set.
Yeah, there you go.
So someone had a question here. It says, "Hey, thanks for bringing coming out tonight. I have a couple of questions. One, what non-development knowledge one might need to start using Meadow and playing with kits?" So the first thing there is that check out the samples on Hackster that will actually show you how to do a lot of the different stuff. And really it's a matter of sort of like Legos, just plug them in and follow the instructions and whatnot. We do have on our website, if you're absolutely brand new to electronics and whatnot, we do have a great electronics tutorial. So if you just go to developer.wildernesslabs.co, and I got up here. So if you come here and then just click on electronics tutorial, then there's a really good, if you want to if you're brand new, this is a great way to start learning about electronics, and it will explain everything that you need to know to, get up and running, and even how to like solder, and if you want to, and how to build stuff. So, definitely check that out. The second question, and like I said, the community, of course, is great. So come in and talk in Slack. We have a beginner hardware channel, which is great. So the other one was, okay, so how does a device, how might you control a device with a mobile app? Does it expose a web API that a mobile app can talk to? So there's a couple of ways to do that. So you could do something like you could create we have this project called Klima. And if you go to GitHub, Wilderness Labs, Klima, you can actually see this in action, in which we have a web server, a local ASP.NET Core web API, and you can talk to that web server from Meadow. So you can call up to that and get information. The other thing is that we're working on our Bluetooth stack right now, so you'll be able to talk directly to the devices over Bluetooth, and we're making really good progress there, and we're hoping that like next month-ish time frame we should have that out in your hands. So there's lots of different options there.
This is something that I'm very looking forward to, the Bluetooth, because I made this little Meadow rover here, and I also made a Xamarin Forms app here, and I made this little interface of a little
nice.
Nintendo controller. So once you pair your Meadow with your board, you can now start already controlling the rover with your phone, which is something that's something like, look, so cool. You can show it around, and yeah, pretty exciting.
Yeah, we're super excited to get that Bluetooth API out. That's really like unlocks a big portion of this. And that's actually one thing that something that to bring up is to just one caveat here is that we are still in beta with this. It's definitely come a long way, and it's very usable today. But there are some things that are still missing. And while we have HTTP client, and we have SSL, so you can talk to your favorite HTTPS endpoint and whatnot. HTTP server. So if you actually want to run a web server on Meadow, like that's still something that we're working on. We're actually working through some of the low-level HTTP listener stuff. We've got an exception there that we have to get through, and but so that's coming down the pipe, and then Bluetooth is coming, and then debugging right now is console.writeline, which is honestly fine. I'm looking forward to being able to set breakpoints and whatnot. And then step through them. That's something that we're working on as well. Most of that's actually done. It's just a matter of wiring it into the IDE and whatnot. So that's coming down the pipe. But yeah, it's a platform in progress. But if you want to build something, don't let that stop you, because you can still do a lot of stuff today. And we should be, we're hoping to hit, V1.0 RTW or whatever you want to call it, pretty soon. So, late spring, summer, or probably summer timeframe. So, definitely jump in and hack on it.
Cool. What about the gRPC? Can you communicate with gRPC?
I don't know, honestly. I think that there's still some challenges with gRPC today. I think that the library that's in .NET that does gRPC is architecture specific. It's like x86. So I think we need to go dig and do some work there to figure out how to support that on Meadow. I'm not even sure. Does that work yet on Xamarin even? I imagine it does, but
I'm not sure.
I don't know, to be honest.
Yeah, me either. It's something. It's important, so we should get it. We should for sure get it supported. I think it's actually just not. I think that the problem right now, from what I understood from the conversation in our community, was that the current library, the current NuGet for gRPC has like an x86 package in it that's, it's runs on kind of Windows only. But we'll figure it out. I mean, gRPC is not. It's not complicated. We'll get it in there.
First Bluetooth, then gRPC.
Yeah, that's right. Bluetooth first, for sure.
Thank you so much for joining us. It was so much fun.
It was.
Thank you for having us. Yeah, it was a great session.
Yeah. Right on time too.
Yeah, I know.
Yeah.
And I hope
and no blue smoke.
Yeah, no magic smoke this time. Everything worked. Yes. So yeah, glad for that, everybody, for having us over. I hope for all the audience people, they feel inspired of what we're doing here as much as we are. And feel free to follow us on our social media and our public Slack, and try to get a hack kit. And these times of pandemic that we're quarantining, why not just stay home and start learning some IoT?
There you go.
Really cool. Yeah.
Good time.
That's a great tip.
Yeah.
Thanks for having us.
Thank you so much.
All right. Thank you.
Bye.
That was fun.
It was. So hope to see you the next time we do a stream. Right now, we're not sure if we're going to do it on Tuesday.
Or on Thursday.
Or both.
It's still up in the air.
See you then.
Thank you.